Hello again, you sick, twisted weather freaks, and happy Thanksgiving, everybody. The special edition of This Week in Weather from weatherist.com. I'm your host and meteorologist, DT, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about this week in weather. A lot to talk about here. First, we'll start out in the immediate, then we'll go into the extended and then longer term. So let's get right to it. This here is your radar. As of this evening, about 9:30, 10 o'clock, you can see most of the precipitation is going up west of the Appalachians. And as a result, you have a lot of warm air coming up all the way into Boston. So, of course, this is, primarily a rain event. So I know a lot of the models earlier, a lot of weather weenies out there were thinking, last week that it was going to be a snowstorm, but no, there'd be little chance for that. Snowstorms don't happen because weather models make them. The upper air pattern has to be in place first. And the idea here is for the weather models to reflect the current pattern and how the pattern is going to evolve. So, that's what has to happen. And you will see a lot of times weather models showing a snowstorm for Mid-Atlantic or New England or the Ohio Valley or what have you, Tennessee Valley, and the upper air pattern is not correct. And that should be a reason for caution here. So this is just one of the examples. So the low is going to track up, and then into probably pass very close to Boston or maybe just inland. So it's a primarily rain event. Maybe even upstate New York might see some snow, but that's about it. You look at northeast Pennsylvania, that's a really wet snow rain mix there right there. That's not really doing much. This is what it looks like here tomorrow morning, 7 a.m. The low is in, I guess it's Elkins, West Virginia, maybe. And then you can see there is some snow in the mountains of Pennsylvania, New York State, upstate New York. But look at the rain, the south winds, even into Boston. This is just a big rain event. Not a surprise, but again, it's a big rain event. And then it leaves, and of course, it goes back to snow a little bit in central and northern Vermont, New Hampshire, Maine. But it's still all rain in Boston, all rain in Rhode Island, Connecticut, and even into Worcester, Massachusetts. So again, this is a rather typical late November, early December type of eastern U.S. low. Now, the next thing to talk about is the upcoming cold and the power of the northern jet here, bringing in these wave after wave after waves of cold fronts. So the first week of December looks very cold, and probably the second week as well. Now, this is a disturbance I posted earlier on the Blue Sky social media page. And you can see here that we have the strong upper air disturbance, which is coming through late on December 2nd. Quite vigorous. This is the European model from early on early Wednesday morning. And you can see in the highlight the very strong vorticity max right there, moving right through West Virginia, the southern half of Virginia, North Carolina. Given the amount of cold air that's in place, this is likely to produce snow showers or a period of light snow. We can see that this was the 6Z Wednesday. You can see the period of light snow there coming through the southern Ohio Valley and the Tennessee Valley, the big Arctic high in the Dakotas. And then here you can see it, again, this is the 0Z run early Wednesday morning. There's the week low in, I guess, close to Charlotte. And you can see air pockets of snow here. Now, as we get closer to this event, starting on Saturday and Sunday, we'll begin to see this in more detail, whether or not the snow showers cross the Appalachians. So, and this is, again, you can see how strong the system is. It looks pretty powerful. Then it kind of falls apart. So, but we'll see. It looks pretty vigorous. And the temperatures here on the morning of December 2nd, look at these values here. Now, this may not seem all that extreme for December. And, if you have a long view and you know what's going on climate-wise, this is not that extreme. But given the fact we don't have a lot of snow on the ground, and given the fact we've had 4 or 5 extremely warm Decembers in a row, to actually have temperatures in the teens on the morning of December 2nd, with really no snow on the ground in western North Carolina mountains, West Virginia, Southwest Virginia, Western Maryland, upstate New York, New England. That's pretty impressive. Much of the Ohio Valley around 20 degrees. We haven't seen this in a long time. So, and you can blow us up a little bit if you want to see more of the temperatures, but it's not bad. That's really not bad at all. And now, beyond that, we have another upper air disturbance coming down on December 3rd. Again, you can see the pocket of snow right in here. Okay, that's what we're talking about, an upper air disturbance coming down. Okay, and there's another short wave coming in this way. So you get these little blobs of energy coming through, And it's going to bring some snow showers on December 3rd, probably to portions of the mid-Atlantic and West Virginia and eastern Kentucky. And this is the morning temperatures for December 4. And again, that's pretty cold. Nothing extreme, nothing shattering, but we haven't seen this in a long time. So to me, and this is just my opinion, even seeing normal or seasonal cold in December, kind of important. Haven't seen in a long time. Okay. Now here is December 5. This here is a reinforcing front coming through. Again, you can see snow showers, rain showers, what have you. This is way out there, 180 hours out. I'm not giving it a lot of consideration, but this is typical of these pieces of energy dropping down, moving through the Ohio Valley, the Great Lakes, and then trying to reform off the coast. But a lot of this stuff forms off the coast. And then you can see December 7th. This is the 12Z Wednesday European. This was 180 hours out, and this was 234 hours out. You can see another Arctic high coming down. So the pattern remains cold. You get these disturbances coming through, it reinforces it, and everything forms off the coast, and there's no real winter storm threat to speak of. Now, that takes us all the way through December 8th, but then things change a little bit. So this is the upper air map. Well, let me see if I can blow this up a little bit here for you. I think I can. Now, the red line here, this is the GFS ensemble, the bias corrected, from the folks at Storm Vista. There you go. And you can see here, the red line is a trough axis. You see how the trough axis, this is December 2nd, this is going to be Monday, is right on the East Coast, exactly on the East Coast. Okay, that's why any low pressure that comes down, any piece of energy coming down in this jet stream is going to form out here to the east. It's going to form east of the trough axis and head out to sea. All right, and that all the models are showing that. This is the GFS at days, this is December 7th. Okay, next Saturday, well, December 7th, a week from Saturday. So it's a long way out there, 258 hours, but you can see the trough axis, again, is right on the East Coast. It doesn't change. But then things begin to change. Now, the GFS model is pulling the trough axis back to the west a little bit, mostly because the ridge amplifies on the west coast of Canada. That changes the wavelength. So the red line, which was on the East Coast, now goes back to the Ohio Valley, the Great Lakes. Now, that's much more favorable because if you get some low pressure, there's obviously some sort of shortwave energy or trough right here. That would generate low pressure on the mid-Atlantic coast, and given the amount of cold air in place, this could be a winter storm. Again, this is way out there. This is speculation. No reason to get freaked out over it. But December 10th, December 11th, and that's on the GFS model. The European is showing the same thing. Again, the trough axis was on the East Coast. Now it gets pulled back by December 10th to Michigan, Kentucky, Tennessee, Alabama. That's more favorable for low pressure development, which could, if the cold air is in place, and I think it will be a winter storm threat. But we're dealing with a lot of speculation here. And this is the operational European, which is, you can see 342 hours at December 7th, December 11th. It's got some sort of decent low on the southeast coast. You got rain, you got snow. It's just to give you an idea of what's happening. Don't take this to the bank. This is just, again, this doesn't mean anything. More important, in my opinion, is the fact that the models are pulling the trough axis back to the west. And at this point in time, the models are pretty good in showing things like where the ridges and the troughs are going to be. So I think this is probably correct. And that makes things more interesting around December 9th, 10th, and 11th. That's all. All right. Now let's talk about the La Nina and El Nino and longer term. So on Friday, I'll put out, I think, my final winter forecast touches a few adjustments. And some of this information will be there, but I thought I'd put it out here in the video. So this is the CDAS, and a lot of people, you get this in tropical tidbits, as you can see here in the lower left corner. And you can see the plot here. This is ENSO region 3.4. This is the important region to determining El Nino or La Nina or neutral conditions along the equatorial Pacific. And you can see that we've been around 1 degree centigrade here for October. Then we jumped up a little bit to a half a degree, which is right on the edge, and then it dropped down a little bit recently. Now, I do not like using the CDAS. I don't think it's particularly accurate, but it shows minus 0.745, which is a weak La Nina event. Okay, that's a weak one. Now, the problem is you look at the other data, and this is from Alex Borman over at Cyclonic Weather. This, again, is the actual sea surface temperatures according to the OISST values. And this is more accurate, I believe. And you can see since September. Now, this here is the zero line, okay? So all this is cold water. But you need to be below here to get La Nina. And as you can see, this is minus 0.5. degrees centigrade. Okay, the water is slightly cooler than normal, but it's staying in this range. It's just not getting down to this level here at a sustained rate. It's not doing that. So this is telling me since September, October, now it's November, and then in November, we're not getting the cold water that we need for La Nina, according to this data. The problem is that the CFS climate model, which is very popular, people use it, continues to be a piece of shit. It's useless. Let me give this, they've been showing this now for most of November, okay? And this is absurd. Let me show you what I mean. Okay, so this is November 27th, but you can go back and look November 20th, November 12th, it's showing the same thing. It has this huge drop right here. So this is October, this is beginning of November, and then it says that all through the month of November, the sea surface temperature should be dropping like a rock. So here we're at minus 0.25. This is now December, where this little point right here is. This is the line, this is January, see January. So this point here is December. Okay, we have November, December in between. It says by the time we get to December, we are going to be at minus 1.25 right here. See that? And we're not. We're just not. Even if you buy this, we're not going to be at minus 1.25 next week. That's not happening. I'm sorry. The CFS is wrong. And it's a piece of crap. It's just absurd. Now, even if you accept this, and let's say you're stupid enough to buy this, okay? Even once you get to January, look what happens. The whole thing collapses and we get rapid warming in February and March. And January for that matter. This is the Australian value for El Nino. And you can see, now in the upper right corner, let me see if I can move this, sync this a little bit. You can see a little more of it. There we go. Minus 0.14. That's not La Nina. It isn't. Now we're cold. This here is the cold value, minus 0.8 centigrade, 1 degree Fahrenheit. So that's where it has moderate La Nina. This is weak, very weak stuff. And you can see it's almost at neutral. And it's not just them. This one I pointed out before. Let me blow this up. You can see it a little more. Okay, here's the international models, and the blue line is the CFS. Look how much colder the CFS is than any other model. I mean, this is batshit crazy. It's not even close. And these other models, the European, the French, the British, the German, the Canadian, they all have it, this dashed black line. This is the boundary right here, see it? Of neutral conditions. They barely get to neutral conditions in December, January, and then it's over in February. Not the CFS. It's much colder. This is an outlier. Could it be right? I guess. But given what we're seeing in the actual trend, no, I don't think it can be right. I don't think it's going to be this cold in the first half of December. The sea surface temperature anomalies and ENSO 3.4 are not going to be this cold by the first half of December. That's just bullshit. It's not going to happen. Just my opinion. I could be wrong, but I don't see how. Okay. Now, the reason why this is important is because this is the overall pattern when you have La Nina. This is ENSO, refers to both El Ninos and La Ninas. This is La Nina, a strong La Nina pattern. And you can see the strong negative anomalies on the west coast of Canada, okay? And that produces, you get flooding in Pacific air. All the cold air is bottled up in Canada. That's a strong one. This is a moderate one. And the moderate one, you have a ridge on the southeast coast. And again, you have the negative anomaly in western Canada on the west coast and the Rockies. And that produces a trough in the southeast states, so you get a crappy winter. That's what we saw in the 2021, 21-22, and 22-23. It was a mild winter with 3 years of La Nina. Okay. Now, this is the upper air pattern, if you want to look at this in more detail, hemispherically. Now, this is, again, you can see, this is 1949 to 2012. This is what the typical La Nina 500 millibar pattern has looked like. This is your negative anomaly right here on the west coast, just like we saw here. Okay, there it is, Western Canada. Okay, this is a different projection, but it's the same concept. And then there's your ridge on the eastern United States, so all the cold air, the lows go into the Midwest, it's eastern United States, the southeast is mild and snowless, and there's your strong anomaly here in the north central Pacific. Okay, that's why La Ninas, you don't get big snowstorms on the East Coast. It's very, very rare, the big snowstorms on the East Coast. You just don't get them. And as you can see, there's not a lot of blocking in Greenland and Canada. None. Okay. This is the sea surface temperature map for the same time frame. Well, actually, it's 2020. And you can see that September through November, when you have La Nina, look how cold the Indian Ocean is. Okay, then you have cold Eastern Pacific, and North Pacific's a little warm, but you can see how cold it is. So this, you have a cold area here in the Indian Ocean, and this cold here. Okay, but what we're actually looking at is this. This is not the same thing, boys and girls. This isn't. This is the actual, this is November 27, you can see right now. So let me blow this up here a little bit so you can see more detail. There you go. Now here we have the entire Eastern Pacific cold. You can see kind of weak La Nina, but look how warm the North Pacific is, especially this blob right here going from Japan into the North Central Pacific. And look how warm the Indian Ocean is. This is not the same as that. It's like the Sesame Street song. One of these things is not like the others. Well, there you go. Okay? So this is a very different La Nina type of pattern. Now, this bears some similarities to what we saw in the historic winter of 2013-14, which was extremely cold and featured a lot of snowstorms in the Midwest and the East Coast. And here, the bubble of warm air was, look how warm the Western Pacific was, and then look at the bubble of warm air in the North Pacific had moved here into the Gulf of Alaska. Now, we're not there yet, but we're close. This is coming east. You go back and take a look at this in October. This was back here, just east of Japan. So we'll see. We'll see. Okay? So that's my first concern. And again, this is from 2013. This was, and you can see again how warm it was in November of that year. So there's some similarities here. There are definitely some similarities here. So now what this produces a different kind of weather pattern. Instead of you getting your normal La Nina weather pattern, which is this one, you end up getting what's known as a positive TNH, which is this. Let me blow it up here. Okay? In January, that's what this is. So you have your negative anomaly here, but the southeast ridge is suppressed further off the coast. And you end up getting a storm track between the negative anomaly in Hudson's Bay, Canada, and the southeast ridge, right along from Texas to Virginia. And that's just a great storm track. You got snowstorms, you got ice storms, you got everything. And the ridge, instead of being in the North Pacific, is now here just off the west coast. And the result is this kind of weather pattern. This is the January one after December, TNH pattern. See this huge anomaly? You get some blocking in Greenland, which forces the vortex further south, and the ridge gets suppressed. And you get this fabulous storm track here. See that? Classic TNH pattern. That's what happened in the winter of 2013-14. Severe cold everywhere. That was the last really severe cold. Well, 2014-15 was also the same thing. But those are the last two cold winters. So, again, I'm not saying that's going to happen here. But the fact that the sea surface temperature map looks like it did then is kind of concerning. And this clearly is not a normal La Nina pattern. This clearly is not. You can just see the differences here. So I am concerned here that we're looking into a different type of La Nina pattern. And again, given the fact that the sea surface temperatures do not match, or on the CFS are completely wrong, I got to tell you, I'm really optimistic about this winter if you like cold and if you like snow. I don't know how cold, I don't know how snowy, but I'm feeling positive about it. I see some things. A lot of people aren't seeing them. That's fine, but this is what I do. People pay me money when I do my commodity forecasting, quite a bit, and to look beyond the box, and that's what I'm saying here. Well, am I going to be right? We'll have to wait and see, but that's where we stand. Anyway, that's the report. Hopefully you enjoyed this and you learned something. This is meteorologist DT from Weather Risk. Happy Thanksgiving, everybody.